Alright, my name is Kaleb Paddock. I'm going over my solutions for problems F5-6 on page 233 and F5-10 on page 261. So for the first steps on 5-6, says to determine the reactions at the smooth contact points A, B, and C on the bar. And it's giving us certain measurements here. So from B to A, we're going to have 0.15 meters. From B to C, we're going to have 0.2, and from C to the force that we're applying is going to be 0.4. That force is going to be 250 newtons at a 30 degree angle rather. So my first step was to free the body a little bit. So that's actually what's shown right here. So just breaking this down a little bit, we're going to have that 250 Newton force. Again, those exact same measurements, and just re-clarifying some of those angles. So first step after that is going to be sum of forces in the x direction. So for this, we're going to have that C force times the sine of 30, because that's going to give us the x coordinate, or x magnitude of that force right there, that reaction force at C, and that's going to be positive. Then we're going to subtract that 250, which is our applied force, times the cosine of 30, which is that angle that they're giving us here, and the cosine of that is going to give us our x direction. So calculating that all out, you're going to get C as a value of 433 newtons. And then from there, you can move on to your sum of forces in the y direction. And for that, you're going to have C times the cosine of 30 plus B, which is going to be that force acting up right there, minus A, which is going to be that reaction force acting down, and then minus 250 times the sine of 30, which is going to give us the y component of that force that we're applying. And of course, that all sums to 0. So simplifying that a little bit, simplified down to A is going to be equal to 250 plus B, and we'll actually calculate this out in a second after we take our moment. So for this moment, we're going to take it about point B. So sum of moments in the B direction is going to be equal to 0. I kind of left the plus and minus up to actually after doing the right hand rule, but for these coordinates, we're going to have 0.6, which is going to be the total length right here from B to that force that we're applying, times 250 times the cosine of 30, which is going to give us the perpendicular component of that, plus or minus that 0.2 times the 433, which is going to be that C force, that C reaction force. Then that plus or minus 0.15, which is this right here, times the sine of 30, which is going to give us the perpendicular component for that reaction force. And that all sums up to 0. So simplifying and plugging in some of the values that we had, we're going to get that A is equal to 577 newtons from here. And then we can just substitute this back into this equation in equation 2 right here to give us that B value of 327 newtons. And that is all that it asks for in problem F5-6. So we can go ahead and move on to F5-10, which is going to be one of the 3D ones that we ended up doing. So again, first step here is to free the body on that. So we're going to have all those exact same measurements, just in a freed up space. But first step after that is going to be the sum of forces in the x direction is of course going to be equal to 0. And the only force we're going to have in the x direction acting along that x-axis is going to be that B in the x direction, which I've labeled right here. And being that you're not subtracting or adding any other forces, that you can leave your bx as 0, which is going to be one of the 3 actually missing components of this that first appears as 6, but it reduces down to 3. Then you're going to do the sum of forces in the y direction, which is more or less the same story. Sum of forces in the y direction. The only thing that's restricting any movement is going to be at point A and point C for your y components. So we're going to have sum of forces in the y direction is going to be AY plus CY equals 0. And then from there, you're going to do your sum of forces in the z direction. So what's actually restricting movement in z? So actually all of these points restrict movement in the z. So you're going to have that A of z, B of z, and C of z minus that applied force of 450 newtons right here should sum up to 0. So with those equations, you move on to taking your moments about each of these axes. So your sum of moments about the x-axis is going to be 0.12, which is going to be both of these values right here, times that negative 450 newtons, because it's acting downwards. Then you're going to add that 0.12 again for this distance out to c, times c in the z direction. And then you're going to add 0.6 times b of z to get to this for your z component there. And then your a of z can be ignored because it's parallel with the x-axis, or it's acting on the x-axis rather. So plugging in some values there, you're going to get an equation that should look like 540 equals 1.2 cz plus 0.6 bz. Then from there, we're going to move on to do our sum of moments in the y-axis. So that equation is going to look similar to the sum of moments in the y should sum up to 0, and that's going to be 0.6 out to your bz again, given by this, plus a total of 1 meter out to your cz force, which is right here, minus that 0.6 times that 450 newtons acting downwards again. Then you're going to have an equation that should look like 270 is going to be equal to 1.0 cz times 0.6 bz. And since these are using the same components, we're going to actually reduce this down, and since your bz forces will actually cancel whenever you set these equal to each other, that will end up giving us our c value. So doing some simple math there, you're going to be left with 270 is going to be equal to 0.2 cz. Divide that out, you should have cz is going to be 1350 newtons. So then from there, you can substitute this back into your equation 5, and you can get bz is going to be negative 1800 newtons. And then finally, solving for your az, plug this back into equation 3, which we have right here. Kind of reset this a little bit, so 450 is going to be on its own over here and positive now. But you have AZ plus this negative 1800 newtons for CZ, then plus, for BZ rather, then plus that 1350 newtons for CZ is going to be equal to 450. And solving for that, you're going to have AZ is going to be equal to 900 newtons, which is actually your 3 missing components. Whenever you're first drawing this out, it may look like that you have 6 total here, but like I said earlier, this kind of reduces because your A in the y direction is acting along all these axes, and it's the same with the B and the CY. And that'll be all for this video. Thank you.